Next example here, and the last example in terms of this technique of using greatest common factor is if you have a polynomial that starts with the first term being negative. If the first, or another word, we say this is the leading coefficient is negative, it's very often a good idea that you factor out that negative sign so that you're left with a polynomial that is then starting with a positive coefficient, especially if you have to do further factoring. It's much easier to factor when you do not have a negative here, when this is positive. So let's take a look at what this greatest common factor would be here. We're ignoring the signs for right now. So 2 is just 2 times 1. 10 is 2 times 5, and 6 is 2 times 3. So the greatest common factor would be 2. Greatest common factor, again, we're ignoring the signs for now, is 2. Now let's take a look at the variable, the x's. We have x cubed, x squared, and x. So the greatest common factor in terms of the variable x would be 2x. So there is our greatest common factor that we have identified. What we are going to do is we are going to use negative 2x because this first term is negative, a negative coefficient. When we use our greatest common factor, when we identify our greatest common factor, we are going to make it negative so that after we do the division, what we're left with inside our parentheses is positive. So again, our answer, we're going to have negative 2x. And our answer, and now the reason for this minus sign here is so that this first term in here is positive. So let's do this division. We have negative 2x cubed plus 10x squared minus 6, all divided by negative 2x, negative 2x. So negative 2 divided by negative 2. This is going to give us the positive we want, positive 1. X cubed divided by x is x squared. Moving on to the next term, 10 divided by negative 2 is negative 5. X squared divided by x is x. And in the last term, negative 6 divided by negative 2 is positive 3. X divided by x is 1. So these x's cancel. There's no x left in this last term. And this would be our answer here. Again, when this first term of your polynomial contains a negative sign, it's a good idea to factor out the negative so that you're left with an expression where there's a positive coefficient here. We can't factor this anymore. This is prime. But if we could, it would be useful that this is positive. But regardless, we're always going to factor out the negative when we can.